Let us solve some equilibrium problems using a RICE table, or sometimes just called an ICE table. RICE stands for reaction, initial, change, and equilibrium. So, we're presented with a problem, and it says for the above reaction, the equilibrium constant using pressure units is 158. And they said initially the flask only had NO2 in it, but they didn't tell us how much was inside. And so initially we do know that then those would have to be 0 if there was only NO2 in the flask. And they did tell us that at equilibrium there was 0.136 atmospheres of pressure for the oxygen in the flask. And then we are supposed to determine the equilibrium amounts for the NO2, the NO, and then the total pressure for the flask. So, let's fill out the rest of this RICE table to see what we can find. Now, for the change, we have 2 moles here and we're using it up, so we can write minus 2x because we don't know how much. And then over here, we can say plus 2x. And then this should be plus x. Now, remember that if we add the initial to the change, then that equals the equilibrium amount. So 0 plus x equals 0.136. That means x equals 0.136 because 0 plus x is just x. So x equals 0.136. That means that we can determine how much NO2 was in the flask at equilibrium because 0 plus 2x equals this. So I just need to take 2 times x, which is 0.136, times 2. That will be 0.272. Now, knowing how much x is actually doesn't help me over here because I don't know how much I started with. So we'll have to find that out another way. And the other way to go is to use the equilibrium constant expression. We have the equilibrium amount constant here. And then we have the equilibrium amounts of 2 of the things. We're only left with 1 variable. We can calculate 1 variable. So let's write out the equilibrium constant expression now. So Kp equals, and since this is all in pressure units, we just write pressures instead of concentrations here. So P of NO squared, because there's a 2 there, times the pressure of oxygen, no square there, all divided by the pressure of NO2 squared. So, there, we have that expression now, and now we'll plug in the values that we know into the expression and see where that gets us. We know the pressure of NO is 0.272. And that's squared. And we know the pressure of the oxygen because they told us. And this is all divided by pressure of NO2 squared. We don't know that yet. So I'm going to simplify this down a little bit. This top thing right here should be 0.0100618. And then if I do a little manipulation, I can switch the position of these two. So multiply by the pressure of NO2 squared on both sides and then divide by 158, and that will switch these two spots. So then I'll get an equation that looks like this. P squared NO2 equals, and then 0.000063682. And then I simply take the square root of that, which should give me the pressure of NO2. So I'll just write the square root of all of that there. I got 0.00798 for the pressure. Now we have all of the equilibrium pressures, so I could just write that right up here. And then if we want the total pressure in the flask, we'll just add all of these up. And for a total pressure, I got 416 atmospheres. So that's how to solve that particular problem.